Hey everyone, welcome back. Hopefully you guys are all doing well. I hear you guys have finally gotten caught up to the last video that I put out, which was like almost 3 weeks ago now. Yeah, things have been a little bit busy with some of my classes and some other stuff in the last little while, but hopefully the videos have all been making sense. I haven't been receiving any emails or anything like that of anything being confusing. But I apologize if any of you have left a comment on any of the videos before this. I have not checked the channel that I upload these videos on in at least I'd say 2 weeks now. So I haven't seen anything new there. Actually, no, that's a lie. I checked it last week and there was nothing there. So if you guys have left a comment asking me to clarify something, I'm sorry if I missed that, but I will check all of that stuff as soon as I finish recording this one. Last time we left off with drawing a graph of a line, or in the fancy mathematical terms that we're using for this unit, linear functions. Let me see if I can get this a little closer. So today we're doing, this is going to be practice graphing lines. So that's what today's lesson is going to be on. Practice graphing lines, which is exciting stuff. So we'll put a smiley face. Yeah, so last time out we talked about the Cartesian plane. So that was just the pair of axes, which is normally the x-axis and the y-axis. This is our Cartesian plane. You don't need to write this down. You should already have this in your notes. And then we practiced graphing, I believe this was the function, y equals x over 2. So basically you put in an x value into like this magical machine, you put in your x value on this side, and it spits out your y value on that side. So you put in x equals 2 on this side, and it'll spit out y equals 1 on that side. And so the operation that it does in the machine, the thing that's being done while your number is in the machine, is determined by this equation. So if you've got y equals x over 2, that means you take the x value and you divide it by 2 and you spit that out as the y value. So if you take your x value of x equals 2, you put it into the machine, it gets divided by 2, and then it gets thrown out the other end, and you say y equals 1. And so you could do that for any x value you want. You could put in x equals 2, or x equals 10, or x equals 20, or x equals 50, and it'll divide it by 2 and spit out an answer on the other side. And so then you take this x equals 2, that y equals 1, and you throw them on the graph, right? We got 1, 2, 3, we got 1, 2, 3. You got x equals 2, y equals 1, and you plot a point. Or you could have x equals 1 and y equals a half, because it's divided by 2, right? So x equals 1, y equals a half. Or you could have x equals 0, 0 divided by 2 is 0, y equals 0, something like that, and you get another dot. I'm zipping through this because this is the last lesson that we did, and we got a lot of graphs to get through today, or at least I hope we can get through them all today. So basically we put those numbers into the machine did the same calculation, spat out an answer, and then we paired off those numbers. We paired this x equals 2 with that y equals 1, and drew it on the graph. That was this one right here. And then we had x equals 1, we paired that with y equals a half, that's this point right here. And then we had x equals 0, y equals 0. Paired them off, put them there. Once you have a few dots, you can kind of see where it's going, and you can just draw a line like that. And so that's the equation of the line. Now, there are a few different things that you can do with these equations, and so what we're going to start doing today is we're going to explore a couple of the other things that you can do to these equations. It's not necessarily always going to be x divided by something or x multiplied by something. So what we're going to do is we will explore a little bit. Ooh, let me get my eraser out here. We're going to explore a little bit with what we can do with these equations and how it affects our graph. So I'm going to erase the title. Do I need to erase the title? Maybe I don't need to erase the title. I'll leave the title for now, and if I need more room, I'll get rid of it later. So what I'm going to do is I'm going to put up an equation. Now you can start writing things down. I'm going to put up an equation. We're going to draw our Cartesian plane. I'm going to try and keep the lines as straight as possible. Let's draw the plane first so that I know how much room I have left to work with. Try and draw it fairly large on your page. I'm a little bit restricted by space on the whiteboard if I want to keep everything visible at the same time, but try and use up a lot of space. I might have to scrunch in some of the tick marks here, but if you've got more room on your page, use as much space as you can. It's a lot easier to graph these things when you take up a lot of space on the page to do it. So like I remember last year, I had a couple of you do some graphing exercises, especially when we were working with quadratics, the unit that we're going to be doing after this one, and the graphs took up like, you know, like how you've got your line sheet of paper, the graph would take up maybe like 4 lines of the page. So it would be about this big on a sheet of paper. And it's really, really hard if you've got a plot, if you've got your Cartesian plane that looks this big, it's really difficult to get any sort of meaningful, you know, placement of dots in any way that you can kind of understand what's going on, right? Like it's too small. It's too small to work with it that way. So try and make your graphs bigger, and I'll show you what I mean as an example. Here's my notes for today's lesson. The graphs, hopefully you can see it, take up like almost half a page. There's only 2 graphs on this page, and I've filled up the entire page. So try and make your graphs as large as you possibly can. Don't take up the entire page necessarily, but like 8, 9, 10, 11 lines on the paper should be good. So make sure you take up lots of space. Use those horizontal lines on the page to mark off these ticks over here. If you happen to have graph paper, then the paper itself has the grid lines, so you could mark off these ones and those ones, all just based on the blue lines on the paper. But I know graph paper is much harder to come by there, so don't stress too much about trying to get some. We can make do with just regular lined paper. But so yeah, once we've got our axes on here, we're ready to start plotting once we actually have an equation. So just remember to label x over there and y over here so you don't get yourself confused later. This is less for somebody who's like trying to mark your work, and more for your own self, that if you mark which axis is the x-axis and which one is the y-axis, it'll be less confusing for you when you're trying to count, oh, okay, you know, x is 1, 2, 3 spaces that way and y is 2 spaces that way. It's a lot easier to confuse yourself if you haven't labeled the 2 axes, because aside from one being horizontal and one being vertical, there's nothing to really differentiate between them, so it's really easy to get that mixed up. So label the axes. It's important for when you're trying to build the graph, and it can be important for someone who's trying to understand it as well. All right, yeah, I've been talking a little bit fast. Let me slow that down a little bit. We'll start by graphing the equation y equals x plus 2. So you can write this down. That's a terrible 2. Y equals x plus 2. So we're going to start off by graphing this equation. Now what we're going to do is we're going to use the same system we've been using so far, where we choose a number for x, we throw it into this magical machine, and it spits out an answer for y. So we'll make a little table where we can put in our x and y values and pair them off. So you can make this table as well, and then when you are done that, we will get started. Let me just make that a little bit more symmetrical, something like that. Put in an x over here, so we'll put our x values in the left column, we'll put our y values in the right column. That's a very narrow y, something like that. There we go. So we'll put our x values in the left column, our y values in the right column, and so we'll just choose some numbers for x, and then we'll throw them into this table. So we'll throw the x values that we choose, we'll throw them into that function, it'll spit out a y value, and then we'll put them in pairs down here. One thing that I haven't done on my axes, I left this out intentionally because I'm hoping that one of you would point this out to the rest of the class. There's no numbers on here yet, right? So this should be 0. The 0 is where the 2 axes intersect with one another. But beyond this point, what I'm going to do is I'm going to label them with 1, 2, 3, 4. So I'll just go over 1, 2, 3, 4, 5, 6, 7. That looks like a Z. 7. There we go. And I'll do the same on the y-axis. If you are on a test or something, if you're feeling a little bit lazy or a little bit short on time, it's fine if you skip. It's fine if you do like 2, 4, 6 that way. If you can, try and fill in every single one. It's easier to not make mistakes if you fill in every single one. But also, if you, instead of doing 1, 2, 3, 4, 5, if you did 10, 20, 30, 40, 50, that's fine too. But then you should choose your x values over here accordingly. You should, instead of plugging in x equals 1 and seeing what happens, if you've got 10, 20, 30, 40 going across the bottom, x equals 1 is right over here, which is really hard to try and graph. So if you've got 10, 20, 30, 40 going across the bottom, you should be putting in 10, 20, 30, 40 down here in the table and 10, 20, 30, 40 into that function right there. But since we're just doing 1, 2, 3, 4, 5, we'll just put 1, 2, 3, 4, 5 going down here. And same thing, when we put it into the function, we'll put in 1, 2, 3, 4, 5 there as well. And then we'll see what the result is. If you put 10, 20, 30 going across the bottom and 10, 20, 30 going up across this side, the graph itself should look identical. So the numbers are important to have, but like you could multiply all of those numbers by 2 and it shouldn't change anything. So don't stress too much about, oh, which number should I put? Should I count by 1s or count by 2s? With practice, you'll figure out, when you need to count by 1s or by 2s or by 10s or whatever. So let's start. Let's start by choosing a few x values that we can that we can put into this function so that it spits out a y value for us. So just looking at the way I've numbered the axes, I want to use some smaller x values. So let's use 0, 1, 2, and 3. Those ones should be fairly straightforward. So I'll put those x values in the table right now, just so that we don't forget to do that later. And what we'll do now is we'll take an x value, we'll choose an x value, like 0 we'll start with. We'll plug it into this function. We'll plug it into this equation right here and see what value it spits out for y. Now the reason we choose the x value instead of choosing the y value is because this equation is already set up to just spit out a y value. Y is isolated. Y is by itself on one side of the equal sign, and all the x's will be on the other side of the equal sign. So if I just plug in a 0 where this x is, then I just need to do a simple addition, I'll get my answer, right? So all of these equations are set up so that you've got y by itself, and that's no accident. That's just how we write them. You choose the x value, you plug it in here, and it'll fill out and it'll give you the y value at the end of it, and you can fill out your table with that. So if we start, we plug in an x value of 0 here, right? We've chosen 0 from over there. So we put in x equals 0, so that means we've got 0 plus 2. 0 plus 2 is 2. So that means that, so basically what we had is y is equal to x plus 2, and we've got, for the x value of 0, that means y is equal to 0 plus 2, so that's telling us that y is equal to 2, right? You can write this down. Please don't write it on the graph because I got to erase it, but I don't want you guys to erase it. So write it down below or something, wherever you've got room. So we've got y equals x plus 2. For an x value of 0, we get an answer that y is equal to 2. So we'll put in 2 right over there in our table. We'll fill out the table first, then we'll put all the dots in. All right, so next one, let's use an x value of 1 instead. So instead of putting an x value of 0 there, we'll put in an x value of 1. So that means that our next line is going to read y is equal to 1 plus 2 instead of 0 plus 2. So we get 1 plus 2 is equal to 3. So we get a y value of 3. And then we can put that in the table next to x equals 1. Why is it next to x equals 1? That's because we plugged in an x value of 1 into the equation itself. So whichever x value you plug in, that's the value that you're going to write your answer beside. Okay, hopefully this is making sense. Most, if not all of you, should have seen this last year, so hopefully this isn't completely new, but I would not be surprised if you guys either forgot it or if there are new students in the class and this is entirely new for you. So yeah, so don't worry too much about which order you do this stuff in for when you're finding these values, just as long as you're lining them up correctly. That when you're using x equals 0, the answer you get goes directly across from it. So don't jumble up where you're putting your y values with respect to your x values, but you could do it in whatever order you want. I could have written this as 3, 2, 1, 0. I could have left them in this order, but then jumped around the table, started here, then gone here, then gone there. I could have picked numbers that aren't next to each other. Let's, instead of doing 0, 1, 2, 3, let's do 0, 1, 2, and 5, just so that you can see that when we're playing connect the dots later, it all still works out. Actually, not 5, let's do 4. 0, 1, 2, and 4. So I'm just going to skip x equals 3. We'll do x equals 0, x equals 1, x equals 2, and x equals 4. And then when we put those dots here, you'll see that a line is still going to be the result that we get at the end of it. So our next one, so we've already done 2 of these. So the next one is x equals 2. So now I'm plugging in a 2 over there, which means we've got to redo this calculation. So that's telling us y is equal to x plus 2. The x is going to be equal to 2 this time. So that means we've got y is equal to 2 plus 2, which is equal to 4. So the 4 goes right there in the table. And we've got just one more, and then we should be done. Now, you could be looking at the table and noticing a little bit of a pattern. As the x value goes up by 1, the y value also goes up by 1, which, based on the equation, makes a lot of sense, right? It's just simple addition. If I increase this one by 1, the whole thing is just going to get bigger by 1, right? If I did 1 plus 2, that's going to be 3. If I did 2 plus 2, it's going to be 4. If I do 3 plus 2, it's going to be 5. So let's do x equals 4. We'll plug in a 4 into that equation. We'll see what we get. X equals 4 goes in there. Means we've got to redo this calculation. You guys are probably getting sick of writing this if you're still writing it at all. And so we get y is equal to 4 plus 2. So that's going to give us y is equal to 6. Because we plugged in our x equals 4 there, we get a y value of 6, and we can put that in down here, right there, in our table. So now we've completed our table. I'm going to erase this calculation going on over here. And we can start plotting those dots. So when x equals 0, first we're going to locate 0 on the x-axis. So remember, that's this axis here. So 0 is right over here, 0 on the x-axis. And it's telling us, so the left column, the x column, is telling us how far do we have to move left or right. If the number is a positive number, so like there's 1, there's 2, and there's 4, if it's a positive number, we're moving to the right. If it's a negative number, we're moving to the left. That's just the way we do it. And for the y values, that's telling us how much we have to move up and down on the graph. So again, if it's a positive number, we'll be moving up, and if it's a negative number, we'll be moving down. So we've got an x value of 0, which means we don't have to move from this starting point. 0, 0 is always our starting point, right? This is technically the point 0, 0. That's 0 for x and 0 for y. Remember, we write the x1 first and the y1 second, just because that's how the alphabet goes. But so 0, 0 is our starting point. That's called the origin. I don't remember if I mentioned that in the last lesson. So that point is our origin, where the two axes meet each other. And that's our starting point for every single dot that we're going to plot. So this x equals 0 is telling us we don't need to move left or right at all from the origin. But the y value is telling us we need to move up 2 units. Up because it's a positive number, and 2 because, well, the number is 2. So from here, from our origin, we move up 2 units. We put our dot right there. And this is at the point 0, 2. Right? 0 because of the x value, 2 because of the y value. Okay, next up we take an x value of 1. So that means we have to move over from our origin. We have to move 1 unit to the right. So we move over to here. This is our new x value. Now from here, how many units do we need to move up? That's going to be told to us by our y value, which came out to be, in this case, 3. So from this spot, we moved over 1 from the origin. Now we have to move up 3. So we go up 1, 2, up 3, right about there. Hopefully that's roughly in line with the point, maybe a little bit over, something like that. Hopefully that's good enough. So that should be in line with an x value of 1 and a y value of 3. Again, if you want, you can sort of put these dotted lines across your page if you think that'll help you, or you can try and find graph paper. I can't keep these lines straight. And then I'll try and make the dots much more obvious, something like that. All right, and you can do the same vertically. You could also put vertical lines going like this, because then you have a little bit of a grid going on, right? That second one is not straight at all. Something like that. Hopefully that's good enough. Hopefully you guys are getting the idea. I hope the dotted lines aren't confusing you with the actual dots, because the actual dots are much larger. Yeah, so if you can get graph paper, it might make the actual graphing easier, but we can make do with lined paper as well. My problem with it is that if I don't, if I'm doing all of this in one color, then you're just going to have lines kind of going all over the place. So I'm trying to use dotted lines and then really fat dots instead, and hopefully that works out all right for you guys. So what we're going to do now, we're going to plot the next point. We've got x equals 2, so we start from our origin again. Start from here, we go over 2 units to the right, because we've been told it's x equal 2, and then it's y is equal to 4. So from here, from x equals 2, we have to go up 4 units. So 1, 2, 3, 4, and we put a dot right there. Okay, hopefully you're beginning to see the pattern now. We've got one more point to plot, so let's go ahead and do that. Remember, this time we skipped x equals 3. We went straight to x equals 4, just so that I could show you that you can skip some of the values and it'll still work out fine. So when x is equal to 4, so we start from our origin, we go over 1, 2, 3, 4 over there, and then we have to go up 6 units. Oh, I can't see that table. We have to go up 6 units for our y value. So we start here, and now we have to go up 1, 2, 3, 4, 5, 6, and put a dot right up there. So hopefully you can see where this is going, because the 4 points are there, and you can probably figure out, without even doing the math, that the missing dot that we skipped over should go right in here. Right? You can see that it sort of all falls along that line. So once you're done, you can just connect all of those dots with a line. I'm going to see if I can make that a little bit fatter, but I cannot. I can't really make it much fatter and also keep it straight, but something like that. I think you guys get the idea, right? And then you can put a little bit of an arrowhead on that end to signal that it sort of goes on forever, and you can do the same thing on the other side as well, to signal that it goes on forever in both directions. So you could have put any x value you want. You could have put in -100 or positive Google or whatever, and you could have these humongous numbers, and you still get a point that falls along this line. So that's why we put those arrowheads on each end to signal that this goes on forever, and we're just showing a small section of it. All right, so I'm actually going to leave that graph exactly the way it is, just the graph part of it right now. And what we're going to do, instead of, I was thinking we'll do 3 graphs, but because we're already 24 minutes into this lesson, and I have a point that I really want to highlight, we're going to change up the plan just a little bit. Let me get rid of this table. The beauties of using a whiteboard is that I don't have to rewrite the table. But so let me explain the plan. What I want you guys to do is I want you to draw another table somewhere on the page, so away from the first one, but not too far away from the graph. So another blank XY table, and leave space to put in a new equation. But we're going to put a second equation on the same graph. So if you have another color, that would be great. I'm going to try and do this one in red. What we'll do this time is I'm going to get rid of this, because that's not helping us right now. This is already cluttered enough. It is normally good practice to label the points. So like you could have labeled this as 0, 2, and this one as 1, 3, and 2, comma 4. I would ordinarily encourage you to do it, and you can do it on this one if you want, but because we're going to be putting a second line on the same graph, you can leave it out this time. The reason we're going to be putting a second line on the same graph is so that I can show you a slight difference that occurs depending on how you adjust your equation. So the first equation we did is y equals x plus 2. I'm going to write that over here next to the actual line that came from that equation. And then everything else that we do for the second one, I'm going to write in red. So the equation we're going to do the second time, let me get rid of this from over here. The equation we're going to do the second time is y equals x plus 1. All right, so we're going to graph y equals x plus 1. We're going to go through the same process with the table, and then we're going to go through the same process with trying to graph it, and we'll see what results we get. So let's begin. We could do the same x values as we did last time. We could do different ones. Let's not skip 3 this time. So we'll do 0, 1, 2, and 3. Why not? Okay, so we'll do 0, 1, 2, and 3 as our x values, and we have to figure out the y values. Now, obviously, I can't write out the calculation over there anymore, so we're unfortunately a little bit short for space, but what I will do is I'm going to get rid of our little function machine guy over here because we didn't really use him. He was more there for comedic effect than anything else. So let's start with x equals 0. So when we know x equals 0, I was going to do this in red. Yeah, let me do that in red. I think black is more visible. So I'm writing in black for now, but then when we graph it, I'll graph it in red so you can tell the difference between the two lines. And if you're doing this in a second color, keep writing it in that second color. Everything for this second equation, do it in the second color. I'm just doing it in black because I think black's a little bit clearer on the board for you guys. So when x is equal to 0, that means y is going to be equal to 0 plus 1. We know 0 plus 1 is equal to 1, no problem. So that means when x is equal to 0, y is equal to 1. I'll put that in black as well, why not? We'll keep everything in black. So when x is equal to 0, y is equal to 1. Now let's move on to the next point. So when x is equal to 1, then this equation changes from, instead of being 0 plus 1, it becomes 1 plus 1, right? Because that's our x value here is equal to 1 this time, right? X is equal to 1, so we put in a 1 there. Y is equal to 1 plus 1, which is 2. So we put in a 2 down here in our table. So now we've got, when x is going up by 1, the y value is going up by 1. It's pretty similar to last time. The values are just slightly different this time. And so now let's go ahead and do the next one. Hopefully this isn't going too fast. If it is, let me know and I'll slow down in the next one. But hopefully this is making sense and this is working out. When x is equal to 2, so when x is equal to 2, we plug in a 2 up here in our equation. So we get y is equal to 2 plus 1. So this tells us that y is equal to 3. And we can put a 3 down in our table over there beside x equals 2. Okay, hopefully that's making sense. And then we'll do one more, which is for x is equal to 3. So if I get rid of that and we say x is equal to 3, then we plug in that into the equation, so we get y is equal to 3 plus 1. So that's going to tell us that y is equal to 4. So we can put that down in our table as well. All right, so that now we've filled out our table, we can plot these points. I'll do the plotting in red. So if you guys are writing in a second color, then you can plot the points in that second color. If you don't have a second color, maybe you could, I don't know, instead of plotting dots, plot squares, plot little boxes, like little boxes on the graph instead, just so that you have a way to differentiate between the first equation and the second one. What's also good practice, especially if you're graphing multiple lines, is to write the equation of the line next to that line. So I could have plotted the second one in black as well. As long as I write this equation beside it, you should be able to figure out which one is which. But I'm going to do it in red and I'll write the equation. If you guys are doing this in exactly one color, then please write the equation of the first line right next to wherever you stop drawing the arrow, just so that you're not confused later on. So now let's plot this. So remember, from the origin, we're going to start from the origin again. So when x is equal to 0, we don't have to move left or right. So this is just going to be moving up or down because our x value is 0 for the first point. So when x is equal to 0, y is equal to 1. So that means we have to move up 1 unit. So we move up to right there. Okay, hopefully you can see that, and hopefully you can tell that it's red. Our second point, when x is equal to 1, y is equal to 2. So x is equal to 1 means we have to move 1 unit to the right, and then y is equal to 2 means we have to move 2 units up. So we put a dot right there. So we've got a second dot right there. Excellent. When x is equal to 2, so that means we start here, we go over 1, 2, and then we get a y value of 3. So we go up 3, 1, 2, 3, and plot it right there. Hopefully you can see where this is going, much like the last one. We've got one more. X is equal to 3. So we start at the origin, we go over 3 spots, 1, 2, 3, and then we go up 4 spots, 1, 2, 3, 4. And we go up 4 because our y value was equal to 4. And so now we're ready to, because we've used up all our points over here, if you wanted you could put more, but I think we're ready to connect these dots, and hopefully this goes relatively straight. Something like that. I'll make this a little bit thicker just so you can see it and see that it's red, hopefully. And then we'll extend that out a little bit in both directions. And great, we've got our second line. I've obviously not drawn it perfectly because I don't have a ruler, and I'm kind of trying to hold up the whiteboard and draw a line on a vertical surface that's not like up against a wall or something. But I think you can see kind of the point that I'm getting at, right? So I'll write in the equation as well. Y is equal to x plus 1 is that second line. So what we can see from this is that just changing the number that you add on at the end, it doesn't change how steep the line is on your graph, right? You could have a line like this, but you could also have a line that was like this, or you could have a line that was almost flat, or you could have a line that's pointed that way. So you could have lines going in any direction you want, but what we've found from drawing these two graphs is that as long as you're only changing the thing that gets added on, basically all that happens is that this graph moves up and down. The actual angle doesn't change, but the whole line shifts up or down on the graph, right? Basically, going from the red line to the black line, all that's really happened is this point moved up, 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 right? So that way we can see that all of those points are basically just shifted up, which makes sense. Your y value tells you how much you're moving in the vertical direction, right? Because this is our y-axis here. And so for one of them, we added 1 to the end of it, so that was our red line. So we added 1 to each of our answers for x. And then for the black line, we added 2. So we added an extra unit. So this point went from being here to up here, from here to up here, from here to up here, because instead of adding 1, we were adding 2 for the black line. So basically all that's happening is this number that you add on at the end. So that in the red equation, that was the plus 1. In the black equation, it was that plus 2. The thing that you add on to the x, after you're done multiplying and dividing, if you have to do any of that, whatever you add on at the end is just moving the graph up or down on the plane. So hopefully that's making sense, and hopefully you guys are sort of seeing the same thing I'm seeing. We'll do a lot more practice with this stuff in the coming lessons. Just a couple of housekeeping things before I let you go. If I happen to be suddenly going too fast, please let me know, because I know, or at least I think I've noticed from the time that I've been recording these video lessons for you guys, is that my teaching style is slightly influenced by the work that I've been doing. So for example, the first time that I started putting out these videos, I was putting them out during a university semester, and I was teaching university level math. I was teaching differential equations at that time, and everybody seemed to be getting it. It was making sense. It was good fun. The following year, I was teaching high school math, but I was teaching it in a more university kind of way. I mean, like a more university level description. Um, because again, the second time that I was putting out these lessons was during a university term. But then the place where I was working for the last few months, we were doing more basic math and we were going at a slower pace than my university courses. So I think that the video lessons that I was recording were also going at a bit of a slower pace. And now these days I'm back in school, so and in particular, one of my professors talks really, really fast. And he talks like he's in a hurry for the entire 50-minute lecture. So if that's the case, if you find that I'm teaching like I'm in a hurry to be somewhere, just let me know and I'll work on slowing that down. Today it might just be because I know I've got stuff to do for the rest of the day and I needed to get this done as soon as I possibly could. But yeah, if I at all rushed in this video, please let me know so that I can slow that down for the next one. I should hopefully be able to slow down for the next one because I'll be done some of the other things that I need to do today. But yeah, I'm going to hopefully get a whole bunch of these videos recorded this week. At the time of recording, it's 1:30 p.m. On the 17th of February, so it's a Monday. And I've got this whole week off from classes, so I've got assignments and stuff to do, but I've got no actual classes. So hopefully that'll give me some free time to record a bunch more lessons and get ahead of schedule, get you guys an assignment, things like that. But yeah, all of those things will be coming your way soon. Sorry, there's been a lack of assignments perhaps in recent weeks. I'm just trying to get back on track with everything. But yeah, aside from all that, hopefully this is making sense, and if you guys need anything, if you have any questions, you know where to find me. Otherwise, I will see you all in the next video. Have a good one.